Hello, Professor Fisher's class. I didn't get to quite as much as I had planned, so I wanted to go over these next two with you all here on this video. These have a couple little extra tricks that the first one did not have. So let's start with our whole kind of idea, right? We're trying to decide whether this is a sine or a cosine function, and I'm kind of seeing this. I mean, it could be either, but when I see that it's like this kind of dip this way, it kind of looks like an upside down cosine. Remember, cosine starts like that, and you can kind of see that, oh, wait a second, it is the opposite of that. So an upside down cosine, that to me is telling me that it's going to be like negative, I don't want to say A. A is the amplitude, but we're going to say that A is negative. How about that? So A is negative. I'm going to erase that minus. Alrighty. So we've got that. We've got a cosine. A is negative. Find the middle line. So the middle line here looks like that line there. And if you do the math on the 100 being broken into 4 spots, that would be 1, 2, 3 spots where I marked in red. So that would be a middle line of 75. All right. Which is actually going to be D. Now the distance from that midline to either the minimum or maximum, mark that in blue. If we trace that over, remember that was 75, and up there in blue we found 125. So it looks like that would be A, which is 50. So we're going to have A is going to be equal to negative 50. Remember, it's a magnitude, or excuse me, amplitude of 50, but since it's being flipped upside down, we know that that's going to be a negative 50. All right, I'm going to zoom in on some of the other parts because now we've got to look at some details pretty close. If I look at the interval of one period, we've got those in green. Like I said, I'm going to zoom in, but that number right there, we kind of want to try to figure out. That nice handy dandy terminology I heard today from you all on the increments is I'm kind of seeing 4, right, increments. And so actually I've got 2 numbers here that give me a fourth of the increment. So once I find that distance, once I find that distance, then I know I can use that to find that distance to help us find that question mark. So let me zoom back out so we can work a little on the side. All right, so if I do 11 pi over 20 minus 2 pi over 5, I need a common denominator of 20, so multiply top and bottom by 4, we're getting 8 pi over 20 for a difference of 3 pi over 20, right? So that's your increment. So that every one of those fourths of a period has a distance of 3 pi over 20. So if I go and use that starting from the pi over 10 and take away 3 pi over 20, then I'm going to find the x value where that question mark is. So that would be pi over 10 minus 3 pi over 20, which would be the same as 2 pi over 20, giving us a difference of negative pi over 20. All right, so that will tell us that the what did you call that? The primary interval of this curve is negative pi over 20 to 11 pi over 20, because that's where the curve completes a cycle. It's kind of an upside down cycle because of that a coefficient being a negative, but nonetheless one cycle completed in that interval. So that's going to help us find the period. Remember the period, if that's a and b, the period would just be b minus a. So you find the difference. 11/20. Now you got to watch this. It's minus from the formula, but another minus pi over 20, which then makes that a plus. So 12 pi over 20 reduces to, see, both divisible by 4, so 3 pi over 5. So we find the period. All right. The period is related to, remember we're going for a cosine of bx minus c plus d. The period, p, is related to the b coefficient. All right, so we had that formula that we used before a couple times in class today. P equals 2, I don't know why my pen just got writing so much bigger. Let me try to fix that. Well, anyways, this is fine. The p is 2 pi over b. All right, and we just found that p is 3 pi over 5. Equals 2 pi over b. And I can multiply to solve for b and get b equals 2 pi times the reciprocal, 5 over 3 pi. The pi's cancel. We get b equals 10/3. All right. The thickness of that is too much for me. Let me see if this fixes it. That's better. All right, so what do we got here? We've got, just recap, we got a equals negative 50, d 75. We just found b is 10/3. We got to figure out c. All right, so c is related to the phase shift. So I'm going to have to scroll back here. The phase shift. That cosine curve, remember, started here in green, and we found that that was negative pi over 20. So that's a phase shift of negative pi over 20. That's a left shift. So remember, in our final formula, that left shift ends up looking like a plus. Instead of a minus c, technically c is going to be a negative value, but then minus the c is going to be a plus in our final result. All right, so let's find some space here on my crazy video now to help us find C. So the phase shift is negative pi over 20. But we had the formula that the phase shift is equal to C over B. So that's going to put a negative pi over 20. And for the phase shift is equal to C that we're solving for, all over 10/3. All right, now we can solve for C. Now this you got to watch just because you're actually multiplying to cancel out the 10/3. You're really multiplying by a 10/3 to cancel out the 10/3. So you don't need a reciprocal in this case. This would be multiplying both sides by 10/3. The 10 cancels with the 20. So we get negative pi over 6 equals C. And that almost does everything for us because that found our last missing piece. So let's put this all together now. This function that we graphed is negative 50, right? Sorry, just going back up to the a cosine bx minus c plus d formula. So negative 50. We chose cosine because it looked like an upside down cosine of 10/3 x. Now you got to watch this. It would be minus c, but c is a negative. So minus a negative would be plus pi over 6. And then finally plus 75. There we go. So that would be that second example. I've actually got one more on the next page if you want to stick around for that. But I think this is kind of nice. We already saw a little more basic one in class. Here's some of the little trickier details that we have to work out. And so if you want to stay with me,